share my screen. Hold on. There we go. All right, so today we're going to be factoring polynomials. Specifically, we're going to be factoring out the GCF, so the greatest common factor. So there's two ways to interpret factoring. The first is if you look at it as a verb, and it is to rewrite an algebraic expression as an equivalent product. And the other way is as a noun, which is to factor, an algebraic expression that is one part of a larger factored expression. So we're going to be looking at both of those today. So first we're going to consider this expression, this binomial, 6x squared plus 15x. What we want to do is make it look like we're about to distribute. So we're going to be going backwards. So what we want to do is we want to take each term in that binomial individually and think of all of its factored pairs. So 6x squared, I like to do something called the rainbow method. So I'm actually going to rewrite these above and below one another. So let me just move this. Okay. So first we're going to look at 6x squared. So I want to think of all the different ways that I can multiply to get 6. So that would be 1 and 6. And 2 and 3. So remember, back in middle school, you would do like a little rainbow thing to show all the different factors of that number. Then at the end, we're going to list out how many of each variable there are. So for x squared, that really means I have an x times an x. So my variables I just kind of push off to the side at the end. For 15x, we have 1 and 15, and 3 and 5. And then there's just 1x there. So now, oops, forgot a comma. There we go. It's a sad little comma. There you are. So now what I want to do is figure out what is their GCF. What's the biggest number they have in common? Well, that would be the 3. And then also I want to know how many x's could I take out of each of them? Well, that would be an x out of each of them. So therefore, the GCF of those two terms is 3x. So you've done GCF of regular numbers before. Now we're just kind of bumping it up and including some variables in it. So it's almost the same process. So if I'm going to show this in factored form, which we're going to do over here, so we said 3x was our GCF, so I got to figure out what's left inside my parentheses. So how I figure that out is I divide each term by the GCF. So when I do that, 6x squared divided by 3x is 2x. And then 15x divided by 3x, that is just 5. So remember, that's going to cancel out. You subtract your exponents. And you'll know you factored it correctly if whatever's inside your parentheses doesn't have anything in common other than a 1. And I guess if I really wanted to check myself, I could distribute, and I would get 6x squared plus 15x again. So this answer is indeed correct. So that's what it shows when I say factoring. We took out the GCF, and all the leftovers went on the inside. So you should have done that also a little bit more of a mild example in 7th and 8th grade. So let's try that again. But first, let's just make sure we can practice finding the GCF, and then we're going to do the factoring portion again. So, like I said, I like to write my numbers above and below one another. So that way I can just kind of highlight or circle what they have in common. Oh, I wanted to use 2 different colors. Shame on me. Okay, let's just start with 12. So we have 1 and 12, 2 and 6, 3 and 4. And I always put them in numerical order, so I know the farther right I go, the bigger the GCF. And then if I have x cubed, I really have an x times an x times an x. And then for 18x, I have 1 and 18, 2 and 9, and 3 and 6. So now I have all my, oh, and I forgot, I have one x kind of hanging out at the end. So we do have a 2 in common, a 3 in common, and a 6 in common. So the biggest one that they have in common is the 6. And then I have one x that I could take out of each of them. So our GCF is the biggest number, which is a 6, and then however many variables I could take out, which in this case is an x. So let's try that again. Oops. Well, let me zoom. There we go. So we have 5x to the 4th. So that's just 1 and 5. And then x to the 4th means I have x times x times x times x. And then 25x squared, that's 1. 5 times 5, so I'm just going to write one of the 5s. 25, and then x times x. So what do I have in common here? I have the 5s, and this time I have 2 x's that can come out. So therefore, my GCF here is 5, and then x times x would give me an x squared. Move this keyboard out of my way. All right. Let's try another. So the next example is cool because